Hello, everyone. So today we have Dr. Rui Gao with us for giving us this webinar. So let me introduce to Dr. Gao with you all. So she is lecturer of the Department of Engineering Education in University of Florida, Herbert Wortham College. She currently teaches transportation courses for engineers. Before joining UF, she worked as an instructor in Department of Civil, Environmental, and Construction Engineering at Texas Tech University from 2017 to 2019. She also worked as a research associate in Intelligent Transport System and Safety Program at Center of Urban Transportation Research from 2015 to 16. She has received her BS degree at Southeast University in 2008 and obtained her PhD degree at University of South Florida in 2015. Her research interests include multimodal traffic safety, sustainable transportation, air transportation, and engineering education. She has conducted more than 10 funded research projects from state DOT as well as national agencies, presented her studies in 4 conferences, and published research papers in the major peer-reviewed journals. So all over to you, Dr. Gao. Once again, thank you for joining us.
Thank you, Saga. Thank you everyone for joining. And for today's talk, I will talk about some my previous projects and published papers related to the traffic safety, and especially using, for example, those traditional crash data that usually means that are readily used from the existing crash database, and of course can integrate it with some other geolocation based data. So that is one part. And another part I will talk about is the emerging data. And okay, so and for Q&A, and of course during my talk, if you want to unmute, that's welcome. And I will also leave some time for Q&A part at the end of today's the slides. Okay. So just a little bit more background about myself, like my research interests. So one major part, of course, would be traffic safety. So to make our transportation safer is one part of my research interests. And from today's talk, you will see the multiple projects that I was involved and some of my research papers. And I'm also interested in the sustainability. For example, during my PhD study, actually, my topic is related to the optimization, that multi-objective optimization. So that also includes the emissions and the fuel consumptions. So we call that like eco-friendly operations. And of course, because of the traffic safety that involves a multi-modal, like walking, bicycling, those we generally consider as the green modes. So those can also relate to the sustainability, and also we also have some other projects that's related to the newer energy, or like the green energy. So that's the second part. And the last part, I think nowadays everyone is at least trying to incorporate the smarter part in our research. That's like the trend, the future. The future is coming. So with the autonomous connected vehicles, or the drones, the UAV, the unmanned aerial vehicle, we call that like drones, right? So those all the different types, the Internet of Things, the sensors could be the video or the LiDAR, radar. So different types of the sensors and AI, the 5G, all those are like the future, not only for the transportation, but also for our daily life. So those parts, of course, as the researchers, they will be integrated in our research, and that's like the trend. So in the second part of today's talk, you will see some of the examples from my research projects and papers. And as I mentioned, I will mainly talk about like first half about the traditional data, and another half about the emergent data. So this figure, I really like this figure. It is from Dr. Mandarin and Bat, those two big names in our field. So from this figure, you can see not only for the crash data, but any type of the data in transportation. So we can have of course, we can have the methodological opportunities. So you can have the breakthrough for the methodology or advanced methodology for your research, like here shows in the left hand, especially for PhD students, when we are doing our research, publishing our papers. Is there any like a methodological contributions? Usually that is like one part, right? So that this figure shows here, like the methodological opportunities. But if we take a look at the right side, maybe I can move my screen. So wait a minute, it blocked my figure. Okay, so if we take a look at the right side figure, that shows the importance of the data. Nowadays, actually, we have more and more data, like the emergent data available, especially from those sensors. And sometimes those are the big data because of the data sets are really large. And for example, the very detailed trajectory data and very detailed sensor data. So with those data, actually, we see the expanded opportunities here. So it's not only this small square here for, or the triangle here, not triangle, sorry, a rectangular here for the methodological opportunities, but it can be expanded greatly. So nowadays, everyone is talking about big data, machine learning, AI, artificial intelligence. That is one of the big initiative or the big topic, hot topic in University of Florida. So AI, all those things actually is related to here because of the emergent data, we have more opportunities here. So we can, of course, we can use some machine learning, some new AI methods. So by using those new data, I would say sometimes because those data are hard to get, some data, not all of them, it could be one contribution, usually for our research. And with those new data, actually, there comes the methodological challenges actually emerge. So we can also do something related to the methodological challenge as well. Okay, so that's like the background and a newer paper. I'd like to just to give some background to you guys. So if you have a big picture in your mind, you may have a better understanding of this content. So another one is, as you can see, this is the most recent paper by Dr. Mandarin and Bat and etc. So they compared the big data, traditional data, and the trade-offs between prediction and causality. So for those who are interested in the data part, so it's not only for the traffic safety from my perspective. So take a look at this several page of it's more like the review paper. So from those big names, you will have, at least you will have like some better big picture in your mind. So for example, the traditional models, like in my highway safety class, I will talk about the traditional statistical models. For example, you guys are familiar with the linear model, the logit model, or the generalized linear model, or like Poisson model, right? Or negative binomial model. Those are like the traditional models. And for highway safety manual or even for travel demand modeling, you can these models are widely involved. And that's like the one part. And the second type of the model here, they call them as the endogeneity and heterogeneity models, or you can also call them as advanced statistical model. So for those advanced models, they emphasize on the methodological parts, so trying to reduce the bias of the parameter estimations. So for those heterogeneity, and later I will also show the example from my pedestrian crash, the safety studies that emphasize for the heterogeneity part. So those are the more like the advanced statistical models. And the third part, or third type usually is like a data-driven methods. So data-driven methods, you can also call them like machine learning or AI methods or big data. So those are more like the data-driven methods. For example, like the supported vector machine SUV, supported SVM, yes, vector machine, supported vector machine learning, and like ANN, and the neural network or deep learning. So all of those actually can be like this part. And actually for the safety, we also have like nowadays it's like the trend. So you can see a lot of publications related to this part. And the last part, the causal inference models actually is not that commonly used for traffic safety. And this part usually emphasize emphasize the causal factors or causality, and but it can have limited predictability. So that means the prediction may be not that accurate, and for the data sometimes not that big. So this part seems to be less touched in the traffic safety parts. Okay, excuse me. And so for my talk today, I will mainly cover some parts like from methodological part. One is like this type, the advanced statistical models, and I also have some parts about the data-driven methods. So causal inference not the emphasis. So just give you some introduction here, and also for different methods. They can emphasize one is predictability. Predictability means, for example, for your fit data and for your observed data, how good is your fit? Like what's the goodness of the fit or good of the fitness? So that's usually related to the predictability. And for the data-driven methods or the machine learning part, they usually can have the advantages from the predictability. But for the causality, or in some literature you will see they call them as like a explainability or interpretability. So those some machine learning data, especially those black box data, black box algorithm can have some limitation for that, but some advanced statistical models can have like a better capability for these parts. Okay, and so that suitability, this is the term I think from this paper they used this name, this term. But for some other paper, maybe you did not see that. But if you are interested, I will definitely recommend you to read that several pages of the review paper. It's a very interesting review paper from my point of view. So and now let's start from like the first part, more from the traditional crash data part. And we know for our world, the types of the data, we can have the continuous data. That's very common, right? For example, how to measure the length, how to measure the weight, how to measure the temperature. So they can be measured and it is continuous. And another part is the discrete data. Discrete data, so that means we can count them. So for example, for crash frequency, it's usually the non-negative integer data. So those we call them as like the count data. So it's the discrete data, of course, but it's not like a limited numbers of the discrete. So, but for the injury severity, actually, it's a little bit different. So injury severity from the crash data, you will see the severity level would be from like a non-injury to could be the minor injury or something, or severe injury or a fatality. So usually it can be 4 levels or 5 levels. And it's the ordered, so it's ordinal. So for this type, we call them like ordered discrete data. Because of the nature of the data, these two types of the models actually are different. And they usually are like two sets of the literature review. So if you are reviewing the crash frequency, so that's like one part. Those models usually are different from those injury severity type. So we generally categorize those crash data to two types: crash frequency modeling or the injury severity modeling. So I also have some definitions here for you. So for example, for the crash frequency, you can count, for example, for the sensors block groups, or maybe you guys are more familiar with the zip code. So for example, for that zip code, during the 5 years, how many crashes for that zip code? How about another zip code? How about 50 zip codes? That would be like 50 observations for your count data. So that's the frequency part. And another is injury severity, usually is the outcomes of the crash that use the most severe injury level involved in that crash. So for example, if the most severe injury for that crash is the pedestrian fatality, so that would be could be like a 5 or 4. So those are the order discrete data. So I'm trying to have these definitions for you guys. So you will, so later when I'm talking about frequency and the severity, so those actually are different, okay. And so now, and for those traditional crash data, the reason that we call them as a traditional crash data is because they are usually readily available from the established database or data sets. Like here, the traffic crash data for Florida, we can, so for example, we can use Signal 4 analytics that is hosted in the UF urban planning or geoplan centers. So for those, we can actually download the crash data. And since the crash data is geolocated, so when we are trying to analyze the data, they can also be integrated or compiled with some other geolocation data. For example, we have a very good data source throughout the United States, that's the census data. So that means we can know the income level, like population, and a lot of the details, like the transportation modes. So all different data from the census data actually can be used or integrated with our analysis. And we also have the road environment data. Some state like Florida states or even the national can have the database about the road inventory data. So we call them as RID. And land use data is also very interesting. So for example, we have the Google Maps, right? Some students may also use the app like Waze or some other, like the Hill is another app. I don't know anyone use that. So from those data sets, actually, we can know the detailed the land use data. And of course, we have the established land use data. That's also like a parcel data. So those parts. So all the different data actually can be integrated and compiled, and to have, for example, have different layers in the GIS, and then we can actually do some analysis and modeling to find some patterns and some results, and to provide the insights for the practical improvement for highway safety. So the first project I'm going to cover, so I will briefly cover this part. So it's about the pedestrian safety study that I did back in Tampa. It's a research center there. So when I was in Qatar. And for the pedestrian, so since we are in Florida, I believe some students are aware that the pedestrian bicyclists fatalities, the rates in Florida is like ranked, usually ranked like number 1 or number 2 in the United States. So for example, although this is the 2016's map, but you can also check this website for the most recent data. So you can see in Florida, if we use the pedestrian fatality and over the population, you can see the pedestrian fatality rate actually are really high. And for those metropolitan areas, usually are ranked like the top 10 could be out of 10 are located in the Florida. So Florida has is facing the big challenges about those vulnerable road users in our roadway. And from our common sense, our experience, we can notice that our roads are usually wider with a higher speed limit. That so our transportation system was built to provide built for the vehicle, or it's like a vehicle-centric transportation system. So they built the transportation system that is wider, that is has a higher speed limit to connect our homes, offices, and the shopping areas. So they are not friendly to the pedestrians and the bicyclists. So that's like from our background or our daily experience, you can have this kind of the feeling, right? So in these projects, actually, we take a look at the detailed crash data and integrated with the land use data, the buses data, and sensors data. So to see what are the factors related to those higher or hot spots, and how about the severe injury? How about the injury severities, and so what kind of the countermeasures we can propose, or what kind of insights from our analysis? So for this project, we the inputs for our data is mainly about the crash data and also census data are the roadway inventory, so RID data and the land use and the basis data. So those are the inputs for this project and this part of the research. And the technical part, so we used some the spatial analysis like using the ArcGIS and also the advanced statistical modeling part. So those are the technical part. Okay, so and the outputs from those analyses are many about, for example, so what are the ranks or the orders of the significant factors that can contribute into the occurrence of the pedestrian crashes or the severity, so more severe. So that's like one part. And for those from the modeling, actually, we can also quantify the marginal effects and how about the percentage and how about the patterns, how about the trends. So all those are from the analysis. Okay, then we can connect those findings to your countermeasures. And these are the tasks actually involved in this project. And, this is the project number. So yeah, as I mentioned, we integrated or compiled these different data sets, and the data connection or data compilation and later the data preparation. This part actually needs lots of efforts. So it's not only me or the PI or co-PI in this project. Also, we involved many graduate students in this project. So especially to help on this part, the data connection or combination, compile the data and then prepare the data. And when we are preparing the data, this part actually, we spend maybe several months in this part. So for example, for the crash frequency, so I already mentioned frequency and the severity are different. So for the crash frequency, we can aggregate the data. So we did not aggregate at the zip code level, actually. We use the census block group level, the BG. Census BG is the smallest spatial unit in the census data, actually. And for example, this is the block group. We can see block group A, B, C, and D. And those red dots actually are the pedestrian crash. So pedestrian crashes typically occurred on the roadways. So you can see the most of those uh, red dots are on the boundaries, right? Only very few is like in the block group. So it's very important to generate the buffer around the those roadways. And how about so how what how, should that be 100 feet or 150 feet or 20 feet or more? Actually, there are some literatures related to this. So these are some details when we are trying to prepare the data. And TAZ, so traditionally for the travel demand modeling, we use the traffic analysis zones. That's usually can be different from the block groups. But nowadays, actually, in the transportation field, we are trying to or replace the TAZ by the block groups, so it's more consistent. And if we have those special unit, then for the so we can have a column, for example, to count how many crashes for that block group, or how many severe crashes, severe pedestrian crashes for that column, or how many non-severe or non-injuries. So those is like we process those data in ArcGIS. And for the crash severity, that is another type of the modeling. So for this part, we call them as a disaggregated crash data. And if we want to consider the land use or the built environment, we also need to consider the buffer. Okay, so this part really takes a lot of time. And so for this one, I showed you one one paper, yeah, from our previous study that we used for the crash frequency modeling, and the methods that we used in this paper. So we compared actually three models. So the first one is a negative binomial model, that is like the traditional statistical model for the count data. And then we also emphasized the second and the third one. So the second one is more like the observed heterogeneity. Heterogeneity means the dissimilarities or difference between the observations, or for example, our for each row or each observation, it could be one block group. So for block group one, block group two, although some like mean or some general factors or could be similar, but they do have some heterogeneity or the difference. So if we can consider those difference, that can also that can actually reduce the bias of the estimation. So from the methodological part, it's usually very important. So the second model we used is to consider the observed heterogeneity. So one common way to deal with that is, for example, you can have the classification of your data sets, like income could be one part of the data sets could be low income, another could be like a high income. So that could be like the binary variable in your data. So you can consider some observed heterogeneity. Of course, you can also have some others. I see some literature, they use the cluster analysis to do that. And the third model, we considered the unobserved heterogeneity. So for this part, we consider the random parameter negative binomial model and combined with the observed heterogeneity. So the three models were explored in this paper, and we use the chi-square likelihood ratio to test like to compare those different models. And another part, so of course this part is important and can provide important insights for the highway safety. And to dig more, we actually did the hot zone identification, and to identify those hot zones or prioritize some the block groups or some zones. for improvement. That is another contribution of this paper or this research. So that can also be very helpful for practical like improvement. How, especially with limited funding, how to prioritize the locations would be very important. So this this is a table showed the results. I'm not going to talk about details from this study. So I just want to quickly show you, for example, so this part is the baseline. So we compared these two models with a baseline model and the log likelihood, and then we use the chi-square to compare, and for the others, actually, is it positively or positively significant positive sign or negative sign? Those explanations are the same with the traditional data, but with those unobserved heterogeneity, how to explain here? So random parameter standard deviations. So those parts actually is different from the traditional one. So if you are interested, actually, yeah, you can take a look at the paper or like this type of the paper. If you search like unobserved heterogeneity models, you can see a lot of this information. So that is one part. And this part, of course, those listed are always with, yes, it's significant at, I believe, 95% or significance level and higher. So those unsignificant, those actually are removed. So from this part, it already can provide some insights for the countermeasures or the improvements. So for example, if we see some this is older social, okay. So those are from the census data. So if for that census block group, there are more older people in this census block group, we can see the correlation is like a negative, or some others like bus stops. So if we see those significantly related, so like the related countermeasures could be do something related to the bus stop improvements, right? Or the lighting or something else. So this part, this kind of the analysis already can provide the insights. And we also added the hot zone identification. So based on that modeling, we can have the, we call them as the expected crash. So with the expected crash, we can identify and use the EB model. I actually talk about EB model in my class. So with the combination of observed data and the predicted data, then we can do the hot zone. So can rank your crash data. So the EB based on the EB methods, and then we can identify the hot zones here. So for example, this study is in Fort Lauderdale. So that is District 4. It's near Miami. So for those major roads, we can see those block groups as the hot zones. So this prioritized low-income area can provide the practitioners the insights if they have limited funding. So some priorities should be given to these hot zones. Okay, so hot zone analysis usually is I would say it's important. So that is one example. And we also can model the data based on the severity, injury severity. And this paper actually emphasizes more for the methodological contribution. And if you take a look at the title, actually, Xin is the one of the graduate research assistants at USF. So when we were conducting those projects, he was the RA, and he's really productive and did a really excellent job. And we also come up with this paper that's more towards the methodology and published in the AMAR. That's a very good journal in our field. So for this one, we emphasize on the random parameters and because it's the injury severity, so it emphasizes the ordered probability model. And since usually for the ordered probability model, there's one part that is the threshold function. So existing order probability model usually has a fixed thresholds function. But in reality, for the data actually, it can vary and it's more reasonable to vary. So for this paper, we emphasize we vary the threshold function. So that is like a one contribution for this paper. And also, we also consider the heterogeneity effects of the variables, not only for the propensity function, but also for the threshold function. So this kind of research, or is more, I would say, more towards the methodology part. Okay, so some results is here, like how about the injury risk propensity and positive sign, negative sign, or means positive related or negatively related, or a decrease or increase, and thresholds. So for some details, yeah, it's better to take a look at the paper, not like during this talk. But I just want to point out some key findings. For example, this paper also emphasized the integration of the built environment for the injury severity. So by using the GIS to pre-process the data, so we also use the buffer to do this part. So for example, we found that the three significant influential factors, especially related to the built environment. So for example, the minority community, like the African American community. So if it's, the crash occurred during that buffer, so you can see it will decrease the probability of the fatality injury fatalities, and also for the incapacitating injury. But for school zone, the trend is kind of different. And we also found 4 factors having the heterogeneous effects on the threshold values, and 2 factors that has random parameters. And also we can have the list or rank about the risky factors for the potential injury severities. And so some details available in this paper, and also how to explain these findings, how to connect these findings to your proposed countermeasures or insights. The details are available there. I'm trying to, yeah, to make the presentation more brief. So that's the 2, I already spent, oh, okay, time flies. So those are 2 major papers that I talked about, or the research projects that we conducted. The papers actually are based on the research projects. Yeah. So the next I will quickly talk about some others. And for the second project is related to motorcycle safety. So I'm not going to talk about details like how we prepared the data. I just want to mention that for the traditional crash data, we can also develop the CMF, the crash modification factor. And these 2 papers we developed based on the FDOT projects actually developed the CMF, the crash modification factor. So for example, for the curve, what is the CMF? And we tried different methods. One is a cross-sectional study, another is a case control study. So you can see that from the traditional data, it's not only just the positive or negative correlation. So not only that, we can also do the hot spot analysis. We can also develop the CMF and etc. Okay, so Next part, as I emphasized, because nowadays we have more data actually that can provide us more opportunities, uh, including the methodological breakthrough. Yeah. So for the emergent data, I prefer to call them as like sensors data because we nowadays we have different types of the sensors. So like the video. So for example here, so from the video we can do the video analytics and to detect the information that we need, right? And for the GPS, especially very detailed, high precision of the GPS data, we call them as the trajectory data. So trajectory data usually has very detailed, like every could be 0.0001 second. How about your speed? How about your acceleration? So with those trajectory data, we can also use that for safety. So I know for the operation part, you use a lot of the trajectory data. So for safety, so for example, can we like automatically detect the risky behavior based on the trajectory data or some others? So those like the surrogate safety measures. So these are the new directions or one direction for the safety study, and some lidar data based on the lidar sensor and some others. And okay, so for this one, okay, not so this is still that motorcycle study, but we used like the eye tracker. Eye tracker can track our attention points, so we can get the eye tracker data. We can also get the very detailed trajectory data from this V-box spot. And from this sensor data, we also developed the CMF for that dynamic sign, the warning sign on curves. So that is one example. And another one is a naturalist driving study. So we call them NDS data. And from that review paper, actually, NDS data was also mentioned as one of the emergent data type. Okay, so NDS data, so that means when we are driving, so it's a naturalist driving. So our cars actually was installed some sensors, including the front radio, back radio, and the sensor to detect our location, detailed location for the trajectory data, and also questionnaire data. So that's the NDS data. And for our research projects, like here, that's also the combined from FDOT and FHWA. So we just requested those three types of data, and actually they have more. They also have the real video data and some others. And this project, we developed some tool because it's a big data sets. Like for example, how to, I cannot play this one, but anyway, so how to get the data information from this from the video. Actually, we developed this tool, and also we have the graduate research assistant from the computer science. So computer science student and also our team developed the video analytics algorithm to detect the pedestrians and the signal. For example, if it's red or green. And just one simple example about this one. So the purpose of this project actually is trying to explore the driver compliant behavior at those pedestrian traffic signs or pedestrian features. And so we compare these four features and use the video data, speed data, and the questionnaire data. So if that driver is categorized as a low risky driver or high risky driver, so that's based on the questionnaire data. And the distraction or high distraction, those are also based on the questionnaire data. But the speed data and also the road inventory data are from the SHARP2. So we can see some findings here. And some more details, I'm not going to talk about details, but if you are interested, definitely later we can discuss. So something related, we also have some like a naturalist bicycle bicycling study. So NDS, we also have MBS, just show you some sensors here. So we used those sensors for that project. Yeah, so I really like, so the idea like not only analyze those data, so when playing with those devices and the sensors, that's also a lot of fun. Okay, so that's the last part. So the last example I'm going to show is the research part that is using the LiDAR data when I was at Texas TTU. So you can see this is one video about the LiDAR information. So from the LiDAR, we can see this kind of the, we can see the, actually we can, from our naked eye, we can see those cars, and there are also some pedestrians and bicyclists. So if we can automatically detect the pedestrian, the presence of the pedestrian, and even if we can track the pedestrian trajectory, that can also help the pedestrian safety at the intersection. So for that one, actually, the important part, of course, we use the machine learning algorithms, the AI algorithms to analyze the LiDAR data. And the first step would be to filter the background. So there are some algorithms, and of course, we can improve the algorithm to suit our data, and then some classification algorithms. Of course, we can use them like deep learning algorithms for this part, and if we can track the object. So this part is still ongoing, and to evaluate the trajectory for the safety, that would be better. So just some quick results here. So especially we use ANN, yes. Okay, so that's, yeah, it's longer than I expected actually. So that's the two parts of the data, yeah, in my talk. And in the future, actually, yeah, the future is coming. We have a lot of more emerging data that we can use for safety. And now I think it's a Q&As or any comments or anything. So that's all for my talk. Thank you.
Thank you for the presentation, Dr. Rui. So we can have some questions. We still have 10 minutes. So folks, go ahead and unmute yourself and feel free to ask questions.
Right.
So I have one question, Dr. Gao. So we have traditional data, and now we are talking about emerging technologies. So what do you think the data generated by using emerging technologies is better than the traditional data, or is it at the same par in terms of the its its usage for modeling and predicting the exactness of the crash frequency or severity?
Yeah, that's a good question. I would say it's not like which data set is better or not, but they both are very useful, and actually they are different. So crash data is more like the direct data to measure the safety. So if a crash occurred, we can know, okay, there's something happening for that location. But for the crash data, usually sometimes it takes time to measure the crash, like several years, 3 years or 5 years to get the crash. So nowadays with this emergent data actually can be, I would say, provide a big opportunity for more, to provide more insights. So for example, if we don't know the crash data for some locations, and especially for the connected and autonomous vehicles nowadays, some just in the controlled environment, or for example, for the micro mobility, like those scooter or those types, right? So we actually have limited crash data for those newer things. So if we use the emergent data, that could be more suitable or can provide the insight for the proactive countermeasures for the safety. So that's a good question. And actually, I'm currently interested in some safety projects could be related to the micro mobility. And I know we have some data, for example, like a scooter, or I don't know about e-bikes for some locations or maybe some cities. But if we take a look at the crash data sets, the traditional crash data sets, you usually we cannot find the category that mention, okay, this is a scooter crash or that is the e-bike crash. So those data are not readily available. So how can we do some analysis for those safety? We need to think about the new data collection methods. So for example, if we can install some sensors for those micromobility, or could be for those e-bikes, or could be at the roadside to monitoring those sites, then to analyze those data. That could be, I personally think that could be an interesting topic or research projects. So like I know these 2 years it's hard. Everyone is working at home, so it's harder to like work very efficiently. But definitely next year when our lives get normal, and I'm interested to at least to apply for some like this kind of the projects either from FDOT or from national. And another interesting thing, like during this time, this pandemic period, so we can see the mobility, some could be the ADT in general decreased, right, in our roadway. But how about the safety? So from our common sense, okay, the total number of crashes reduced maybe. But I see, and during my class as well, some students also see some reports from the Wall Street journals, I believe. So they notice that actually the severities of fatality crashes actually increased a little bit for some locations or during some period of time. So what's the reason behind those? And can we do something related to safety during this special period? That's also could be a interesting topic related to, could be related to the paper, maybe more like a paper style.
Maybe people are speeding up more because they are getting empty roads now.
Right.
So
Yeah.
that's why
Yeah.
might be frequency has decreased, but severity is expected to increase in that case.
Yeah. Mm-hmm. Good point. Yeah.
So guys, any other questions from anyone else?
Or just some comments
Okay,
or
yeah. So Carla, you can unmute yourself and you can go ahead.
Hi, thank you for your presentation, Dr. Hue. I would like to know about the CMF that you presented and how the accuracy of curve parameter was assessed to build the presented CMF.
are you talking about this one, the motorcycle one?
Yeah, this one.
So this CMF. So what do you want to know? I did not. So can you repeat?
Okay. Yeah.
Mm-hmm.
Because we have some parameters I couldn't see, but I think it's radius maybe.
Yes,
Like or
it's
sharp curve.
radius.
Yeah,
Yes.
and how do you evaluate the values? And I don't know where it comes from GIS or from project the design. I mean, how would
So
you evaluate?
for the curve data, so if you are talking about the curve data, like the
Right.
curve radius, those data actually is we obtained that from the road inventory data set. So it's a RID data from the FDOT, and actually we can request the detailed data, and I believe maybe a partial of those RID data is available, like openly available. So from the FDOT, they have this type of the data. It's a road inventory data.
Okay. Thank you.
Yes. That's a good question.
Anyone else?
Yeah, or like in the future, if I got some projects, maybe I can involve some students who are interested.
Sure, sure,
Yeah, really.
definitely, definitely. And
Yeah.
I think we are gonna upload this recording to our YouTube channel. So GatorITE has launched their YouTube channel now. So all the
Oh,
participants can get to visit your presentation again. Thank you so much, Dr. Rui, for taking out time despite of your busy schedule. And you must be taking online classes with a toddler and a baby to take care of. We are really glad to have you.
thank you, thank you.
Okay.
Yeah,
Okay,
nice
so
to
we
be here.
should, okay, so everyone, see you soon for the next webinar.
Thank you,
Yeah, thank you, Dr. Gao.
thank you.